Okay, guys, so the next problem is about absolute extrema, which is related to the extreme value theorem, EVT, or the so-called Weierstrass theorem, but that name is so hard to write that I just advise you to write EVT and you're done, you're good. I cannot for my life spell Weierstrass, it's extremely complicated. Anyway, so these problems I think are on the easier side because, as I said, the derivatives that we had before, they're not conceptually hard, but it's so incredibly easy to make a computational mistake. Here, computationally, it's much easier, but you just need to understand the algorithm that's behind this problem. So I have this doc that I also share with you, but I'm gonna explain it briefly now. Which just explains again the steps to solving these types of problems. So first we have the definition of the extreme value theorem, and the definition is a very fancy sounding thing for something that's extremely intuitive. So it basically says if a function is continuous over a given interval, then it must have an absolute maximum and minimum within this interval. That's it, right? So the math explanation is slightly longer, but that's it. So if you basically have some function starting from here to here, and it is continuous throughout the whole interval, then there is surely gonna be a minimum somewhere, and there's gonna be a maximum somewhere, or it could go like this way, and then the maximum would be here and the minimum would be, I guess, at the endpoint. So this is literally all they're telling you. If the function is continuous over the interval, and it has to be a closed interval, right? That's one of the important things. Then it is going to have a maximum and a minimum, and then we can find them. So how do we find them is the next question. There's a couple steps, and I advise you to just go through this process multiple times in order to get used to it. But the first thing you should do when you see your interval is make sure it's closed. What does it mean for it to be closed? It means that it has to have the square brackets on both sides of whatever numbers you're given. The numbers don't matter, but it has to be closed on both sides. And if it isn't, then you stop because you cannot apply the extreme value theorem. Okay, now on the exam, you probably won't ever hit this case because you need to solve it, but you need to firstly explain. You need to make it explicit that you have checked the interval when it's closed. And then it's similar for the next condition, which is you need to check if the function is continuous over the interval. How do you do this? You find the domain first, and if the given interval, whatever it is in the domain, then it is continuous over that interval, right? But you need to, again, explicitly write it down. You cannot just skip it and then expect to get the points. You might, I'm not sure, but I think you might lose points if you don't write this. So please make sure to have it in your solution. And then, once we've made sure that the interval is closed and the function is continuous over this interval, it's time for us to find the critical points. Now, in order for us to get the critical points, we need the derivative. And once we have the derivative, we check for the values where the derivative is either 0 or undefined. When does it get undefined? Typically when we have division by 0, right? So these are the two cases we're looking for, either the derivative being 0 or the derivative being undefined. And then we note for which x's this happens, right? And then what do? Then, oh, by the way, this is a very important note that I have here and I forgot to mention. When you're finding these values for which the derivative is 0 or undefined, you need to make sure that they're in the interval that we had to solve for, right? So in the beginning, you were given some interval. When you find these points, you need to make sure they're within the interval. If they're not, you don't consider these points, okay? They're not critical points. They're not relevant at all, okay? That's important. And then once you have a list of these points, you are just gonna evaluate the original function at each point plus at the endpoints of the interval. Endpoints are these two guys, okay? So you evaluate at these 2 points as well as the critical points that we already found. And then you're gonna get some values, and then you just pick the minimum and the maximum, and these are your final answers. Okay, that was quite long, and I don't expect you to have remembered it, But let's just go through the actual problems in order to apply this. And I'm gonna I'm gonna often refer to this document so that you can get used to, going through the algorithm. So the first function that we're given is f of x equals 2x cubed minus 3x squared minus 36x. Okay. And the interval is minus 4. So what was the first step? The first step was to check whether the interval is closed, right? So let me go back to the outer doc. This is our first step. Okay? Okay. So now I'm not completely sure if you need to make it super explicit, but you could just write down one interval minus 4 to 4 is closed. So we can so let me think about how we should write down. Maybe you could write something like, so this requirement for using EVT extreme value theorem is satisfied, right? Because if it's open on either end or on both ends, then it's not, this requirement is not satisfied and you can not use the Weierstrass theorem. Wait, what am I writing? Satisfied. Okay, good stuff. That's the first thing. What's the next thing? Next thing is to check if the function is continuous over this interval. So we are done with that part, and now we are here, okay? So how do we check if the function is continuous over the interval? We just find the domain. Now here we're extremely lucky because this is just a polynomial and there's no square roots, no fractions. So this means that this function is actually continuous everywhere. So its domain is just R, or minus infinity to infinity. And there's a very specific way the professor typically expects you to write this down. So please just make sure you understand how it works. So we analyze the domain. You actually don't need to write it explicitly as a domain, so here's how you should write it. You can write it this way. F is continuous over the interval minus infinity to infinity. Okay, so that's the domain basically, but it's just rephrased. Instead of writing that this is the domain, I'm writing that f is continuous. C0 means continuous. So f is continuous over the interval minus infinity to infinity. If you're wondering why I have two sets of parentheses, that's because in some cases, your domain might be a union of something, right? So that's why we have an outer set of parentheses for the entire domain, and then we might have multiple different sets of parentheses inside. But in this case, it just looks like this, minus infinity to infinity. And then you write it the following way. Therefore, f is also continuous on the interval that we're looking for, from minus 4 to 4, and you write by restriction. Okay, so if we have the number line and we have minus infinity and infinity, and we know that it's continuous everywhere, right? It's continuous everywhere. Of course, by restricting the domain to minus 4, of course it's going to be continuous here as well. That only makes sense, right? This is super intuitive, but you need to write it down because that's how we do math. We just explain everything, right? Okay, that was the second step. So that is a check, right? We can move on. And here you can actually write down the full sentence. So you can write down the following. F is continuous over the closed interval minus 4 to 4. Therefore, by EVT or Weierstrass theorem, if you get to understand how to write this thing, therefore by EVT, f attains its, and now you can either write maximum and minimum, or like extrema, or like absolute extrema is probably best. Absolute extrema within that interval of -4 to 4. Okay, so you're basically confirming that because these two are satisfied, because f is continuous over that interval -4 to 4, it follows that it must have an absolute maximum and an absolute minimum within that interval. Okay, all right. Moving on, what's the next step? Next step is finding critical points. But before we actually start looking for the specific points, we need to find the derivative, okay? So point number 3 is derivative. Or like critical points, I'll just write it down as critical points, but the derivative is like a prerequisite for finding critical points. Critical points. So f prime of x. Now I'm not gonna explain in too much detail how I'm calculating this. Plus, this is actually an extremely easy derivative, right? Here, there's no product rule, no chain quotient rule, whatever. It's just very, very simple. Let me copy the expression first. Okay. So yeah, I'm not gonna explain this in detail because I don't want the video to be too long. I have more basic videos on derivatives for the midterm. So I plug this down, so that's 2 times 3. It's going to be 6x squared, because I subtract 1 from the exponent, minus, take this down, so it's going to be 2 times 3 is 6x to the first power, which is just 6x, minus 36. Okay, that's my derivative. Now, from here, what was the rule for critical points? Critical points are those points where the derivative is either 0 or undefined. Now, undefined you could get if you had a fraction and you had 0 in the denominator, but here clearly we don't have a fraction. So undefined is not really possible, but we should look for the values where f prime of x equals 0. So that's our f prime of x, meaning 6x squared minus 6x minus 36 should equal 0. Because I have a multiple of 6 everywhere, I could just divide by 6. So it's going to be x squared minus x minus 6 equals 0. And then I need to just solve for x. I need to factor out, right? So the method that I use is I firstly think about two numbers that when multiplied give me minus 6. So what are the possible combinations? It could be minus 6 times 1, or 6 times minus 1, or minus 3 times 2, or 3 times minus 2. I guess that's the possible combinations. And now out of these, I need to find the pair that when summed gives me this coefficient. In this case, this is just minus 1, right? It's not explicitly written, but it's minus 1. So if I take minus 6 plus 1, this is minus 5. It doesn't really help. 6 minus 1 is 5, not what I want. Now, minus 3 plus 2 gives me a minus 1. So that is my set of values that I'm going to plug in. So I'm going to have x, and then I take the first value, minus 3, times x, and then I take the second one, which is plus 2, equals 0. Therefore, we have x equals 3 and x equals minus 2. So these two are, note, candidates for critical points, but they're still not confirmed to be critical points. And now you're like, why? Because I told you that critical points are those values for which the derivative equals 0. We found them, but here's the point. You need to make sure that they're within the right interval. So we care about the interval minus 4 to 4. Is 3 within that interval? Yes, it is. So that's a valid critical point. Is minus 2 within that interval? Yes, it is, right? It's between minus 4 and 4. So in this case, both values are indeed critical points, but you should always double check, because if we had, for example, 6, it wouldn't have been a critical point because it isn't relevant for us, right? Okay, now we have critical points. The last step is to just calculate the original function at each of the critical points. So that would be 3 and minus 2, plus each of the endpoints of the interval, which means minus 4 and 4. Okay? So I'm gonna have to calculate f of, let's start with the endpoints, f of minus 4. So the original f function was 2x cubed minus 3x squared minus 36x. So that's just f of x. I'm just copying the function because I don't remember it. And now if we calculate f of minus 4, that's 2 times minus 4 cubed minus 3 times minus 4 squared minus 36 times minus 4. I'm actually going to use a calculator for this. Not that it's super hard, but my brain is not braining much. And I think just in order to be quicker, I could use a calculator. Minus 3 times minus 4 to the power of 2 minus 36 times minus 4. So that's minus 32. And I just keep doing that for the rest of the endpoints plus the critical values. Let me just bring this one row down. So now I'm just gonna try with 4, which is like the other critical point, the other endpoint, right? So f of 4 is 2 times 4 cubed minus 3 times 4 squared minus 36 times 4. So let's see how much that is. 2 times 4 cubed minus 3 times 4 squared minus 36 times 4. That's minus 64. And then I also need to test at the critical points, right? So that's f of 3 and f of minus 2. So f of, let me do it here, f of 3 equals 2 times 3 cubed minus 3 times 3 squared minus 36 times 3. So that's 2 times 3 cubed minus 3 times 3 squared minus 36 times 3, which is minus 81. And last, we need to do f of minus 2, which is like the last critical point, right? So we have 2 times minus 2 cubed minus 3 times minus 2 squared minus 36 times minus 2. Okay. So I'm just writing it down in the calculator. 3 times minus 2 squared minus 36 times minus 2, which gives us 44. And now we're almost done. So we have these values, and whichever one is the smallest is going to be the absolute minimum. Whichever one is the biggest is the absolute maximum. Okay? So from here it follows that f minimum is minus 81, right? This is the smallest number I have. And then f maximum is 44. That's actually the only positive number. So it's definitely 44. And that's my answer to this problem.